So in this video we'll see how to solve a problem using KCL when current source is given. In the first video we solved it using a simple circuit. In the next one we used resistors, currents, and with unknown directions of current we solved. But in this case we were given 1, 2, 3, 4 resistors and 3 voltages. This value is 4 volts, and we were also given the direction of current for this junction. So to solve this particular problem we need to first find the junctions of the problem. So now what is a junction? When two or three branches are meeting at a point, that is called a junction. If you are considering this particular circuit, see, this is one branch, this is one branch, and this is one branch. So this particular point is called as A, and the potential difference at point A is called as VA. If we consider this particular so this is called a junction. This particular point is called a junction because this is a branch, this is a branch, and this is a branch. So this is called as B. This is VB. So now we were given for this particular junction, we were given that our current is in incoming direction. But for this junction we were not given any current. So first let us note down the directions of the current. So for this particular circuit, see, whenever you are not given the directions of current, whenever the directions are not given, you can take all the directions in outgoing side. See, all the directions will be going in outgoing side. So now, so this is my I1. This goes in the outgoing direction. This is my I2. This also goes in outgoing direction. And this point is I3. This goes in outgoing direction. This is I4, which goes in outgoing direction. This is I5, which goes in outgoing direction. Now we gave the outgoing directions for all our currents, and we need to find the values of VA and VB. This is the final result we need to get after solving the problem. Now what we'll do, we'll apply KCL equations for junction A and junction B. So if we consider for junction A, so this will be for junction B. Junction is also called as node. So this is for junction A. So in our junction A, what are the currents we are having? We are having I1, I2 and 6. The 6 is already in the incoming direction. So what will be, see, we are having I1 6 amperes and I2. Now, sum of incoming currents is equal to sum of outgoing currents. We were given an incoming current, and our I1 and I2 are outgoing currents. So how we can give the equation for this? I1 plus I2 is equal to 6. This is our equation. From this particular equation, we need to derive I1 and I2 values. If we are checking this particular node, this I1 is moving from VA, means our VA is at higher potential. So I1 value will be VA minus, then it is passing through this particular voltage. See, it is moving from positive terminal to negative terminal. If current is moving from positive to negative, we need to consider the value as negative. If it is moving from negative to positive, then we need to consider it as positive. Since it is moving from positive to negative, you will have minus 4 divided by, and what is the resistance for this? 1. So I1 value is VA minus 4 by 1, and your I2 will be, so this is your I2. So it is moving from VA to VB, which means VA is at higher potential and VB is at lower potential. So VA minus VB, and what is the resistance we are having here? By 2. So this will be your second value, I2 value. Now we'll substitute I1 and I2 in this equation so that you'll get the final result. Now for junction B. So what is our junction B? We are having I3, I4 and I5. Since all the currents are outgoing, you can write I3 plus I4 plus I5 is equal to 0. Now we need to determine I3, I4 and I5 values. So if we check for this I3, it is moving from VB to VA, which means our VB is at higher potential and VA is at lower potential. So I3 is equal to VB minus VA, and it is under which resistance? By 2. So this will be our I3 value, and our I4 will be. So now this is our I4. It is moving from VB. So we'll have VB, and it is moving in this particular direction, that is it is moving from negative terminal to positive terminal. So if it is from negative to positive, then we need to consider it as positive. So VB plus 2 by, and what is the resistance we are having here? 3. This is our I4 value. For I5, so it is moving from VB. So VB, and see here, the current is moving from VB in this direction, that is from positive to negative terminal, that is we will get minus 3 by, and what is the resistance we are having? 4. If we substitute these values in I3, I4 and I5, we'll substitute both in the same way and we'll derive the equations. So for junction A, if we are finding the values, so our equation is I1 plus I2 is equal to 6 for junction A. Now if we substitute I1 and I2, what we'll get? So VA minus 4 by 1 plus VA minus VB by 2 is equal to 6. If we do the LCM, we'll be getting it as 2. So 2VA minus 8 plus VA minus VB is equal to 6. You'll get 2VA plus VA is 3VA minus 8 minus VB is equal to 12, and 3VA minus VB is equal to 12 plus 8, which is 20. So your first equation will be 3VA minus VB is equal to 20. This is your first equation. Now let us find for junction B also. So for junction B, we need to substitute I3, I4 and I5 values. So what is our I3? VB minus VA by 2 plus I4 is VB plus 2 by 3, and I5 is VB minus 3 by 4. This will be equal to 0. If we calculate the LCM for this particular part, we'll get it as 12. So 6VB minus 6VA plus 4VB plus 8 plus 3VB minus 9 is equal to 0. We'll get 6VB plus 4VB is 10VB and plus 3VB minus 6VA. 8 minus 9 is minus 1 is equal to 0. So 13VB minus 6VA is equal to 1. This is our second equation. Now what we'll do, we'll solve 1 and 2. So rewriting the equations, our first equation is 3VA minus VB is equal to 20. And our second equation is minus 6VA plus 13VB is equal to 1. In order to solve these equations, we need to either make VA coefficients as same or VB coefficients as same. So let us make VA coefficients as same. So in order to make it same, we will multiply equation 1 by 2. So what we'll do, we'll multiply it. So after multiplying, what we'll get? Equation 1 into 2. 6VA minus 2VB is equal to 40. and this will be minus 6 VA plus 13 VB is equal to 1. So if we solve this, we'll get 12, 11. 11 VB is equal to 41 and VB will be 41 by 11. Now substitute this VB value in any of the equations. So substituting VB is equal to 41 by 11. What we'll get? So now substituting VB is equal to 41 by 11 in equation 1. What is our equation 1? 3VA minus VB is equal to 20. If we are substituting 3VA minus 41 by 11 is equal to 20, then we'll get 3VA is equal to 20 plus 41 by 11. 3VA is equal to, if we take the LCM, we'll get 11 into 20 plus 41 by 11. That will be 220 plus 41 by 11. And 3VA is equal to 261 by 11. Your VA will be 261 by 33, which is 87 by 11. So your VA is 87 by 11 and your VB is 41 by 11. So this is how you solve the problems when the current source is given in KCL. So this is the concept of Kirchhoff's current law, and in the next we'll deal with superposition theorem.